بسم الله والحمد لله والصلاة والسلام على رسول الله سيدنا Muhammad sallallahu alayhi wasallam. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we'll be solving Mathematics Code 0580, Paper 2, Variant 2, February, March 2023. Bismillah ar-Rahman ar-Rahim. Let's start. Alright, question number 1. From the list of numbers, write down for part A a cube number and for part B a prime number. Alright. So we're given a set of values and we're asked to find a cube number using this set right here, headway. Right, so what is a cube number? A cube number is any integer raised to the power of 3. So for example, the cube number of 2 is 2 raised to the power of 3, which is equal to 8. Now, an easy way of determining whether this is a cube number or not, for example, is by taking the cube root of this number. So the cube root of 12 will give you an irrational number, so hence this is not the answer. Cube root of 15 would give you an irrational number. However, the cube root of 27 will give you 3, because 3 raised to the power of 3 would give you 27. Hence 27 is the answer. Now for part B, a prime number. What is a prime number? A prime number is a number that's only divisible by 1 and itself. Obviously 12 is not a prime number because it's a multiple of 2. 15 is a multiple of 5. 27, we just said that it's equal to 3 raised to the power of 3, hence it's not a prime number. However, 29 does not have any factors except itself and 1, hence it is the answer. 91 is a multiple of 7, by the way, and 93 is a multiple of 3. Just use your calculator, man. Alright, question number 2. We're given two vectors v and y, where v is equal to negative 1, 3, and y is equal to 2, 5. Find for part A v minus y, and for part B 2 multiplied by the vector v. Right. So we're given two vectors, and we're told to subtract vector y from vector v. How do we do that? Well, when it comes to addition and subtraction in vectors, we add or subtract the corresponding components of each vector. So for example, let me just write down v minus y, negative 1, 3, minus 2, 5 would be equal to negative 1 minus 2, which is negative 3, and 3 minus 5, which is negative 2. And this is the vector v minus y. On to part B, 2 multiplied by the vector v. Alright, so 2 multiplied by the vector v, which is negative 1, 3. You'll just multiply the constant 2 or the scalar 2 by each component in the vector. So 2 times negative 1 would be equal to negative 2, and 2 times 3, which is equal to 6. This is the answer. Alright, question number 3. On the Venn diagram, shade the region A intersection B. What does that mean? Well, we're given two sets, set A and set B, and we're asked to find the intersection between these two sets. And it's actually pretty obvious where the intersection is. It's just this region right here. You don't even need that much brain cells to solve this question. On to question number 4. We're given a sequence, and for part A, we're asked to write down the next number in this sequence. Alright. Now, if you were to look closely and examine the sequence written right here, you would notice that there's a common difference of negative 6, meaning that if we start with the first term and we move one term forward, you would be subtracting this negative 6. Same thing. 17 minus 6 will give you 11, and 11 minus 6 will give you 5. Obviously, so 5 minus 6 will give you negative 1. And this is the next term in the sequence. Now, part B, which is written in un is equal to kaza, which helps you determine the value of the term with respect to its position in the sequence. Now, since the sequence has a common difference, we would then conclude that this is an arithmetic sequence. Now, the general equation of the nth term of an arithmetic sequence is written as un is equal to a plus d multiplied by n minus 1, where a is the first term in the sequence, which is 23, and d is the common difference. Now, since a is equal to 23, we'll just write that down as 23 plus d, which is negative 6. So negative 6 multiplied by n minus 1. Just expand and simplify this. You'd get 23 minus 6 and plus 6, which is equal to 29 minus 6, and this is equal to un. And to verify if this is correct or not, just substitute n with any value, 1, 2, 3, 4, or 5, and you'll get the corresponding term. So 29 minus 6. And alright, on to question number 5. Factorize completely ag minus 2g squared. Alright, as you can see, both terms have the variable g in them, meaning that we can factor out g, giving us ag multiplied by 8 minus 2g. Now, as you can see inside the bracket, 8 and minus 2g have a common factor of 2. Their highest common factor is 2, meaning that we can also factor out 2, giving us 2g multiplied by 4 minus g. And you cannot factorize this any further, hence this is the answer. 2g multiplied by 4 minus g. Now answer question number 6. Without using a calculator, work out 4 over 7 divided by 8. You must show all your working. Now, when it comes to division and fractions, when it comes to division and fractions, we tend, or you actually just flip the fraction of the second term and then replace the division operation with a multiplication operation. Now, so 4 over 7 divided by 8 is the same thing as 4 over 7 multiplied by 1 over 8. We just flip the fraction of 8 over 1, which would be 1 over 8, and then replace the division operation with a multiplication operation. Now this is equal to 4 over 7 times 8, which is 56, and then you can divide top and bottom by 4, giving you 1 over 14, I think. This is the answer. Now, question number 7. Part A. Solve 15t plus 8 is equal to 4 minus t. We're asked to solve for the variable t, my bad. Now, to solve this, you can just add t on both sides, giving you 16t plus 8 is equal to 4. And then you can just subtract 8 from both sides, giving you 16t is equal to negative 4. And then you can just divide by 16 from both sides, giving you t is equal to negative 4 over 16, which is equal to negative 1 over 4. Negative 1 over 4. Now, for part B, got a fraction on the left hand side, 25 minus 2u all divided by 3 is equal to 2, and you're asked to solve for the variable u. Now, since you got a fraction on the left hand side, that's not very good. We want to get rid of it. How can we do that? Well, you can just multiply by the constant 3 on both sides. So when we multiply by 3 on both sides, you'll end up with 25 minus 2u is equal to 6. And then you can subtract 25 from both sides, giving you negative 2u is equal to 6 minus 25, which is equal to negative 19. And then you can just divide by negative 2 from both sides to find the value of u, which is equal to 19 over 2. On to question number 8. Calculate 0.3 squared, giving your answer in standard form. No. First of all, just grab your calculator and write 0.3 squared. You should get that 0.3 squared is equal to 0.09. Now, what does that mean? Give your answer in standard form. Well, standard form is a way of writing numbers, writing large or very small numbers, in the way that a times 10 raised to the power of b, where a is greater than 1 and less than 10, and b is an integer. Now, for example, we have a very large number such as 800, and we want to write that down in standard form. How can we do that? Well, 800 is equal to, in standard form, 8 multiplied by 10 raised to the power of 2. These two are the same thing. You can apply the same concept with 0.09. 0.09 is equal to 9 divided by 100. And 100 is equal to 9 over 10 squared. And then you can just also write this fraction as, you can write this fraction as 9 times 10 raised to the power of negative 2. This is the answer. Now to question number 9. Solve these simultaneous equations. You must show all your working. عندنا أول equation 3x minus 2y is equal to 19, and the second equation x plus y is equal to 3. دلوقتي أنت عندك طريقتين ممكن تحل ال two simultaneous equations دول. One way is by making one variable in either equation the subject and then substituting that in the second equation, or by just the elimination method. Now, personally, I would start by using the elimination method because these two equations are linear, they are not quadratic or cubic. Now, since we'll use the elimination method, I would start by eliminating the variable y. How would we do that? Well, we would multiply by 2 in the second equation. So if we rewrite that down, 3x minus 2y is equal to 19. And then after multiplying the second equation by 2, you'll get 2x plus 2y is equal to 6. Now to get rid of y, you'll just add both equations together, giving us 5x is equal to 25, and then you can divide 5 from both sides to find the value of x, which is equal to 5. So x is equal to 5. Now to find the value of y, you can just substitute that value in either equation, this, or even this equation. You got the same value for y. Now, I'll personally use this one because it's easier. Now, so 5 plus y is equal to 3. So y is equal to negative 2. So x is equal to 5 and y is equal to negative 2. Now, on to question number 10. In the diagram, AB and CD are parallel lines. The lines CB and AD intersect at point X. Alright, so AB is equal to 3, AX is equal to 2, and BX is equal to 2.7, and CD is equal to 7.5. Find the length of BC, this length right here. Very interesting question. Now, so first of all, since we got two intersecting lines, we can conclude that these two angles are equal. Why? Because opposite angles and intersecting lines are equal. Now, and we also have two parallel lines, which means that these two angles are also equal. Same concept with these two angles, because they alternate to each other. Now, since we got two triangles, CDX and ABX, that have the same size of the corresponding angles, we can say that these two triangles are similar. Now, since these two triangles are similar, we can then conclude that the ratio of the length between these two is equal to the ratio of the lengths CD and AB. So I can say that CX divided by BX is equal to CD divided by AB. The ratio between their corresponding lengths are equal because these two triangles are similar. Now, what's the value of CX? Well, CX is unknown, so I'll just call it X for now. So X divided by BX, which is 2.7, is equal to CD, which is 7.5, divided by AB, which is 3. Solve for X by multiplying 2.7 on both sides, and you'll end up that X is equal to, I think that would be 6.75. Yep. Alright. Now, we're told to find the length of BC, and BC is equal to CX plus BX. And we already found the value of CX, which is 6.75. So 6.75 plus BX, which is already given 2.7, is equal to 9.15. Alright. So question number 11. Find the highest common factor of 12x raised to the power of 12 and 16x raised to the power of 16. Now, بص انت بدل ما تدور على الهايست common factor between these two terms, you can work it in two ways. ان انت تدور على highest common factor ما بين 12 و 16 والhighest common factor ما بين x raised to the power of 12 و x raised to the power of 16. ماشي. أول حاجة 12, what are their prime factors? PF. The prime factors of 12 is just 2 squared times 3. والprime factors بتاعت 16 is 2 raised to the power of 4. So their highest common factor between 12 and 16 is equal to 2 squared. That's the highest common factor in common. Now, what is the highest common factor between x raised to the power of 12 and x raised to the power of 16? It's very obvious, x raised to the power of 12. You can factor out x raised to the power of 12 between these two terms. Now, so we got the highest common factor will be 12 and 16, and x raised to the power of 12 and x raised to the power of 16. Now then you'll just have to multiply these two by each other to get the answer. So 2 squared times x raised to the power of 12 will give you 4x raised to the power of 12. Now, question number 12. In a regular polygon, the interior angle and the exterior angle are in the ratio interior to exterior is equal to 11 to 1. Find the number of sides of this regular polygon. Alright, so we know the ratio that interior to exterior angle is equal to 11 to 1. حلو أوي. فهنقول هو 11 to 1 is interior to exterior. حلو. Now احنا ممكن نقول ان that the exterior angle is equal to the variable x. فلو ال exterior angle is equal to x, that means the interior angle is equal to 11x. حلو. And we know that the interior angle plus the exterior angle would give us 180 degrees. So interior plus exterior would give us 180 degrees. That means that 11x plus x will give us 180. So 11x plus x is equal to 12x. 12x is equal to 180. That means that x is equal to 180 divided by 12, which is equal to 15. Now x ديت اللي هي الاكستيرير انجل. حلو قوي. دلوقتي احنا عارفين لو الاكس اللي هي الانتيرير انجل that means دلوقتي E معلش E اللي هي الاكستيرير انجل is equal to 15 degrees. فكده الانتيرير انجل would be 11 times 15, which is equal to 165 degrees. تمام. نجيب لون تاني. دلوقتي احنا عارفين الايكويشن بتاعت الانتيرير انجل is equal to n minus 2 times 180 divided by n, which is equal to interior angle here 165, where n is the number of sides of the regular polygon. I can just solve by n by multiplying by n from both sides. For n times 2 times 180, n minus 2 times 180 is equal to 165. n expand to get 180. n minus 360 is equal to 165. And so by subtracting 165 and adding 360 and then dividing, get that n is equal to 24. That's good. That's the number of sides of the irregular polygon. Alright, on to question number 13. The diagram shows the speed time graph for part of a car journey. Calculate the total distance traveled during the 10 seconds. Alright, we know that the total distance is equal to the area under the graph. Okay, you can see الراجل أصلا كتر خيره he separated the graph to us. عندنا right angle triangle and a rectangle. To find the total distance traveled, we'll just have to find the area under this graph. فعندنا rectangle side lengths 8 and 10, فالاريا بتاعته تكون 8 and 10. بعديها الاريا بتاعت right angle triangle will be 10 minus 8, which is 2. دوت كده 2. والهايت بتاعه is 10. half base times height, which will give us half times 2 times الهايت اللي هو 10. الاريا هتكون 80 plus 10, which is just 90 meters. Question number 14. The diagram shows the sector of a circle with center O and radius 9 centimeters. The length of the chord PQ is 6. Calculate the length of the arc PQ. You should know that the equation of any arc is equal to theta divided by 360 multiplied by 2 pi r, where r is the radius of the circle and theta is the angle between the two radii subtended by the circle. Now, احنا عاوزين we already know that the radius is 9 centimeters because P and Q form a chord and so if P and Q form a chord, that means that P and Q are both points on the circumference of the circle, which means that OP and OQ are the radii of the circle. Hello. So we want to find theta, and we have the triangle OPQ عندنا كل السايد lengths بتاعته. That means that we can use the cosine rule to find this angle theta right here. So the cosine rule says that the cosine of theta is equal to the sum of the squares of the side lengths beside the angle. So which is 9 squared plus 9 squared minus the opposite side, the square of the opposite side, which is 6 squared, all divided by 2 multiplied by the side lengths beside the angle. So 2 times 9 times 9, which is equal to, let me just put down my calculator, 9 squared which is equal to 7 over 9. So cosine theta is equal to 7 over 9. And to find theta, you just have to take the inverse of cosine. So theta is equal to inverse of cosine of 7 over 9, which is equal to 38.9 degrees around its one decimal place. Alright, now we found theta, and you can just find the arc length using this equation right here. So theta, which is 38.9. Make sure to store your value of theta, by the way. Okay, so 38.9 divided by 360 multiplied by 2 pi times r, which is 9 centimeters. This would give you an answer of um, 6.11 rounded to, sorry, 6.12. So 6.12 rounded to 2 decimal places. Perfect. Now, for question number 15, simplify 3125 times w raised to the power of 300, 1025, or raised to the power of 1 over 5. Now, if you have, for example, ab raised to the power of n, it would just be equal to a raised to the power of n times b raised to the power of n. So you'll just write this as 3125 raised to the power of 1 over 5 multiplied by w raised to the power of 3125 o raised to the power of 1 over 5, which is equal to 5 times w raised to the power of 3125 raised to the power of 1 over 5. Now, this part right here, how do we do it? Well, if you have something that's, for example, written as a raised to the power of n, all raised to the power of m would be equal to a raised to the power of n times m. So 3125 times 1 over 5 will give you 625, I think. Yes. So this would just be written as 5w raised to the power of 625. That's the answer. Now, on to question number 16. Y is inversely proportional to x squared. When x is equal to 3, y is equal to 2. Find y when x is equal to 2. Now, y is inversely proportional to x squared. We can write that down as y is proportional to 1 over x squared. Now, we can remove this proportionality sign and replace it with an equal sign by replacing this one with a constant that we'll call k. So y would be equal to a constant, a random number that we do not know yet, k over x squared. Now, we're given a set of values of x and y, where x is equal to 3 and y is equal to 2. We can substitute these values to find the value of k. So, when y is equal to 2, x is equal to 3 squared. X is equal to 3. So I can then solve this equation and solve for k. So k would be equal to 2 times 3 squared, which is 2 times 9, which is 18. That means that y is equal to 18 over x squared. Now, we're asked to find the value of y when x is equal to 2. Just put x to be equal to 2 in this equation, and you should get that 8 divided by 2 squared, which is 4, would be equal to 9 over 2, or 4.5. Alright. Alright, on to question number 17. We've got ABCD is a cyclic quadrilateral where ABX is a straight line and PQ is a tangent to the circle at point A. Angle CBX is 85 degrees and angle BAQ is 55 degrees and angle CAD is 42 degrees. For part A, find the angle CBD. Okay. So we're told to find the angle CBD, this angle right here. So where's CBD? This one. Alright. Well, if you look closely, you'll notice that the angle CBD and angle CAD, this one, they're both equal because they're both subtended by the same arc CD. Therefore, the angle CBD is also 42 degrees. Alright, on to part B. I used the white color. Part B, find the angle ACB. Where is angle ACB? This one right here. Alright, angle ACB and angle ADB, they're both subtended by the same arc. They're both subtended by the same arc AB. Just had a brain lag. Alright, so angle ACB and angle ADB, they are subtended by the same arc length. So these two angles are equal. However, we still do not know the angle ADB. But there's a theorem that states that the angle formed by the tangent and the chord through the point at which it passes through is equal to the angle formed by the chord in the alternate segment. So as you can see, this angle right here, which is 55 degrees, it's formed by the tangent at point A and the chord AB. And there's the other angle that's formed by the chord AB, which is this angle right here. So that means that ADB is equal to BAQ, which is 55 degrees. So this is also 55 degrees, and this is 55 degrees. So angle ACB is 55 degrees. On to part C. Find the angle ADC. Where is angle ADC? Oh, this one right here. Okay, this one. Now, for this part, we'll have to use the cyclic quadrilateral theorem, which states that the opposite angles in a cyclic quadrilateral add up to 180 degrees, meaning that this angle right here, ADC and ABC, they both add up to 180 degrees. And we can find the angle ABC, which is this angle right here, by subtracting 85 from 180. 180 minus 85 will give us 95 degrees. So this angle right here is 95 degrees. That means that this angle, ADC, plus this angle, which is 95 degrees, will give us 180. So ADC plus 95 is 180. So ADC is equal to 180 minus 95, which is equal to 85 degrees. All right, let me pick another color. All right, on to part D. Find the angle BCD. Where is angle BCD? BCD. This one right here. Oh boy. Okay. So angle BCD is the sum of the angle ACB and ACD. We already know the angle ACB, which is 55 degrees. We only need to find the angle ACD, this one, to be able to find the angle BCD. So how do we find the angle ACD? Well, we know that, as you can see, ACD and ABD, they're both subtended by the same arc AD. So again, ACD and ABD, they're equal because they're subtended by the same arc AD. Okay, so if only we can find the angle ABD, we'll be able to find the angle BCD. And thankfully, we can calculate ABD by subtracting 42 and 85 from 180 degrees because this is a straight line. So let me just write down ABD is equal to 180 minus 42 minus 85, which is, let me put that on my calculator, 53 degrees. So if angle ABD is 53 degrees, that means that angle ACD is also, so therefore angle ACD is also equal to 53 degrees. That means that angle BCD is equal to angle ACD plus angle ACB. So 53 plus 55 degrees, that will give us 108. All right, very nice question. All right, part E. What is the angle PAD? Where is it? Angle PAD is right here. Okay, how do we find the angle PAD? All right, so to find angle PAD, we'd have to subtract all of this from 180 degrees because PQ is a straight line. However, we do not have this angle. What is it equal to? Well, this angle, which is BAC, is equal to BDC because they're subtended by the same arc. So these two are equal because they're subtended by the same arc BC. And we can find this angle by subtracting all of this from 55. And we said that all of this, which is ADC, so basically let me just write down that B, let me write down that BAC is equal to angle BDC, which is equal to um, this angle, this huge angle, ADC minus ADB. and we already know that ADB is 85 degrees. So 85 minus A, sorry, we already know that ADC is 85 degrees. So 85 minus ADB, which is 55, will give us 30 degrees. That means that 30 degrees is equal to, sorry, BDC is 30 degrees and BAC is 30 degrees. So this one is 30 degrees. Now we can finally find the angle PAD by subtracting the sum of this from 180. So um, angle PAD is 180 minus, we said 30 minus 55 minus 42, which is equal to 53 degrees. Interesting. All right. On to question number 18. Two solids are mathematically similar and have volumes 81 centimeter cubed and 24 centimeter cubed. The surface area of the smaller solid is 44 centimeters square. Calculate the surface area of the larger solid. All right. Okay, so just bear with me. I'll just draw a random shape. Let's just assume that this is 3D. I can't be bothered to draw a cube or anything. So this is the smaller shape, which has a volume of 24 centimeter cube. So apparently this shape has been enlarged by a scale factor k, meaning that we multiplied all the side lengths of this shape to form another shape, a larger shape, which has a volume of 81 centimeter cube. Again, so we multiplied all the side lengths of the original shape. Okay, so we multiplied all the side lengths of the original shape by a scale factor k to form this new shape that has a volume of 81 centimeter cube. So what happened to the volume? Well, the volume has been enlarged by a scale factor k raised to the power of 3. So the side length has been multiplied by k and the volume has been multiplied by k raised to the power of 3. That means that 24 times k raised to the power of 3 is equal to 81, meaning that k raised to the power of 3 is equal to 81 over 24. So we can take the cube root of 81 over 24 to find k, meaning that k would be equal to 81 over 24. That would give us 3 over 2. So this is the value of k. Now, we were also told that the surface area of the smaller solid is 44. That means so the surface area of the smaller solid is 44 centimeter squared. And we want to find the surface area of the larger one. Now, as we said that, we have multiplied all the side lengths by scale factor k, which is actually 3 over 2. What happened to the surface area, though, however? Well, the surface area has been multiplied by a scale factor of k squared. So volume is k raised to the power of 3, side length is k, and surface area is k squared. So that means that 44 multiplied by k squared will give us the surface area of the larger one, which I'll just call x. That means that x is equal to 44 times k squared, which is 3 over 2 squared, which is 9 over 4, which is equal to, that's 4 by the way, which is equal to 99 centimeter squared. That's the answer. Now, for question number 19, find the values of x when 6x plus y is equal to 10 and y is equal to x squared minus 3x plus 10. Alright, so you have one linear equation and one quadratic equation. We're told to find the solutions of x and, oh, just x, okay, perfect. Now, to do this, you'll have to make y the subject in the linear equation, or you can actually just straight up substitute this into this. So we'll say that 6x plus y, which is actually equal to this, so 6x plus x squared minus 3x plus 10 is equal to 10. You can just subtract 10 from both sides, ending up with x squared minus plus 6x minus 3x, which is plus 3x is equal to 0. And then you can just factor out x, which is equal to x multiplied by x plus 3 is equal to 0. Now you have two solutions for x. One is when x is equal to 0, or x plus 3 is equal to 0. So one solution is that when x is equal to 0, and the other solution is when x is equal to negative 3. That's it. Alright, on to question number 20. Find the nth term of each sequence. Given part A, a sequence which states that -1, 0, 7, 26, and 63, and so on. Alright, what I prefer to do is first by finding the common difference between each consecutive number, each consecutive term. So from -1 to 0, we basically added 1. And from 0 to 7, we added 7. From 7 to 26, we added 19, and from 26 to 63, we added 37. Okay, now since the common difference, there is no constant common difference, we would have to take the differences of these differences. So from 1 to 7, we added 6, and from 7 to 19, we added 12, and from 19 to 37, we added 18. Again, there is no constant common difference, so we would have to take the difference of the difference of the differences. So from 6 to 12 we added 6, and from 12 to 18 we had to add 6 as well. And finally we have a constant difference, a constant common difference. And since this is the third difference that we took, this means that this is a cubic sequence, and a cubic sequence is written in the form a n raised to the power of 3 plus b n squared plus cn plus d, where a, b, c, and d are all constants. Now, to find all of these constants, there are four special equations that you should be familiar with to be able to find a, b, c, and d. Now, the first equation states that 6 multiplied by the constant a is equal to the third difference. I'll explain that in a moment. And the other equation, second equation, states that 12a plus 2b is equal to the second difference. And for the third equation, 7a plus 3b plus c is equal to the difference of the first two terms, which is u2 minus u1. And finally, for the fourth equation, states that a plus b plus c plus d is equal to u1. Okay, let me bring another color. Now, first equation, 6a is equal to the third difference. The third difference refers to this number, this value right here. So 6a is equal to the third difference, which is 6, meaning that a is equal to 1. So un is equal to n raised to the power of 3. Now we'll have to find the value of b. So we have to use the second equation. So 12a, which is 12 times 1, plus 2b is equal to the second difference, and the second difference refers to this value right here, the first difference in the second difference. I know this sounds so complicated, but just bear with me. So 12 plus 2b is equal to 6, meaning that b should be equal to -3. So un is equal to n raised to the power of 3 minus 3n squared. Now we need to find the value of c. So we'll use the third equation. So 7a, which is basically 7, plus 3b, which is 3 times -3, which is 9. So 7 minus 9 plus c is equal to u2, which is 0, minus u1, which is -1. So 0 minus 1 is equal to 1. And c should be equal to 3. So un is equal to n raised to the power of 3 minus 3n squared plus 3n. And finally, the fourth equation to find the value of d, which says that a plus b plus c plus d is equal to u1, where a is equal to 1 and b is -3. So 1 minus 3 plus c, which is 3, and then plus d, which is equal to -1. So d would just be equal to -2. And finally, un is equal to n raised to the power of 3 minus 3n squared plus 3 minus 2. And this is the nth term. Alright. Now on to part B. Let me erase all of that. Okay. In part B, we have another sequence, which is 24, 12, 6, 3, 1.5, and so on. As you can see, there's an obvious pattern. Each term we're multiplying by half. So from 24 to 12, we're multiplying by half. From 12 to 6, that's 12 times 1 over 2, and so on. Now, this type of sequence is known as a geometric sequence or an exponential sequence, which has a form of nth term, which is written as un is equal to a multiplied by r raised to the power of n minus 1, where a is the first term in the sequence, which is in this case 24. So a is equal to 24, and r is the common ratio. The common ratio is basically the ratio between two consecutive terms. So r is equal to 12 over 24, which is also equal to 6 over 12, which is also equal to 3 over 6, and so on. So we know that a is 24, so un is equal to 24 multiplied by r, which is 1 half, raised to the power of n minus 1. And this is the answer for part B, question 20. On to the next question. A car travels, question 21, a car travels 14 kilometers correct to the nearest kilometer. This takes 12 minutes to correct to the nearest minute. Calculate the lower bound of the speed of the car. Give your answer in kilometers per hour. We're asked to calculate the speed, the lower bound of the speed of the car. Now, what is the equation for calculating speed? Well, speed, we know that speed is equal to distance over time. Okay, so we have the distance in kilometers and time in minutes. We want the lower bound of speed, so the least value of speed. To find the least value of speed, we'll have to find the um, lower bound of distance and divide that by the upper bound of time. Why? Because speed is proportional to distance. So if we want to decrease speed, we would have to decrease the distance. And since speed is also inversely proportional to time, to decrease the speed, we have to increase the time. Okay, now, alright, so what are the lower and upper bound of the distance? Well, 14, its lower bound is 13.5 to the nearest kilometer, and its upper bound is 14.5. That's the distance. And for time is 12 minutes, so its lower bound should be 11.5 to the nearest minute, and its upper bound is 12.5. Okay, so the lower bound of speed would be the lower bound of distance, which is 13.5. So 13.5 divided by the upper bound of time, which is 12.5, which is equal to 1.08 kilometers per minute. Question number 22. The diagram shows, one moment. The diagram shows a triangular prism ABCDQP of length 7 centimeters. The cross section is triangle PAB with PA is equal to 4 and AB is equal to 5. An angle PAB is 90 degrees. Calculate the angle between the line PC and the base ABCD. Where is the line PC? It's this line right here. Let me use a lighter color to make it more obvious. Right, okay, it's not working. So PC, the angle between PC and the base ABCD, this base right here. So what he means by the angle between PC and ABCD is the angle between this line PC and this diagonal AC. As you can see, it's kind of obvious that this is a right angle triangle, APC. So to find this angle right here, which I'll call theta, we need to find the length AC, which is basically the diagonal of this rectangle ABCD. And to calculate this diagonal, we'll have to use Pythagorean theorem. So AC is equal to the square root of the sum of the side lengths. So 5 square plus 7 square, which is equal to 25 plus 49 is equal to the square root of 74. Now, let me just redraw this triangle ACP. So it would look something like this. Okay, So this is A, this is P, and this is C. Alright, you got a 90-degree right here. The diagonal AC is the square root of 74. And AP, we're given that AP is 4 centimeters. And we want to find this angle theta. You'll use the, what's it called? The SOHCAHTOA trigonometry. So theta, tan of theta would be equal to the opposite divided by the adjacent, so which is 4 divided by the square root of 74. You'll take inverse of tan from both sides, so theta is equal to tan inverse 4 over the square root of 74, which is approximately equal to, one moment, 24.9 degrees. I hope that's correct. Right, on to question number 23. Simplify the fraction 5x squared minus 19x plus 12, all divided by x squared minus 9. Okay, now to simplify this, we first have to factorize the top and bottom. To factorize the top, you just use the quadratic formula or your calculator, and it should be written as 5x squared minus 19x plus 12 can be factorized into x minus 3 times 5x minus 4, and in the denominator it's just x squared minus 9. X squared minus 9 can be factorized as difference of two squares. We can factorize it and write it as x minus 3 times 5x minus 4, all divided by x minus 3 and x plus 3. How do I do this? Well, let me explain. Now, let's say that we have, for example, any quadratic equation written in the form x squared minus b squared. Alright, so to factorize this, the form of writing the way of writing the factorized way is just x minus b and x plus b. Okay, now back to the question. We got our fraction here and we got two common terms in the top and bottom which we can just divide by, leaving us with 5x minus 4 and x plus 3. And we cannot simplify this any further, hence this is the answer. Now on to question number 24. Alright, on to question number 24. The probability of Jamie hitting a target is 1 over 3. The probability that he hits the target for the first time on his nth attempt is 64 over 2187. Find the value of n. Alright, so basically the probability of Jamie hitting the target is 1 over 3, and the probability of Jamie not hitting the target is 1 minus 1 over 3, which is 2 over 3. So not hit is equal to 2 over 3, and hit is 1 over 3. Okay, now Jamie has been attempting to hit the target for a while now, but all his attempts have failed. Until a certain attempt, which is the nth attempt. Okay, he finally has hit the target on the nth attempt. The probability of this happening is 64 over 2187. This is not an OR probability, but an AND probability. We'd have to use the AND probability, not the OR. Why? Because he must keep on not hitting the target and then hit the target on the nth attempt. So basically the probability of him, now let's form the equation. So 64 divided by 2187 is equal to him not hitting the target for n minus 1 attempt. So 2 over 3. Let me so 2 over 3 happening n minus 1 times, which is basically a raised power of n minus 1, and then times 1 over 3, because he only hit it once. Okay, and we multiplied because they use the AND probability, not the OR probability. Now we just have to solve for n. To do this, you'll just multiply by 3 on both sides. So when you multiply by 3, you'll get 64 times 3 divided by 2187, which is 2 over 3 raised to the power of n minus 1 is equal to 64 divided by 729. Okay, now solve for n, you can just take log base 2 over 3 in both sides. So let me do it here. Log base 2 over 3 of 2 over 3 raised to the power of n minus 1 is equal to log base 2 over 3 of 64 divided by 729. Now, log base 2 over 3 of 2 over 3 raised to the power of n minus 1 is just n minus 1, which is equal to log base 2 over 3 of 64 over 729. Just use your calculator. You should get 6. And then you can add 1 on both sides to find the value of n, which is 7. That's it. On to question number 7. On to the final question. Question number 25. We've got a function f of x, which is equal to x raised to the power of 3 plus 1. Find f inverse of x. Okay, now to do this, let's just write f of x, but instead of f of x, we'll just write y. Y is equal to x raised to the power of 3 plus 1. And to find the inverse of this function, you'll have to replace y with x and x with y. So x is equal to y raised to the power of 3 plus 1. And then to find the inverse, you'll just your goal is to make y the subject, and that would be your inverse. So to make y the subject, you'll have to subtract 1 from both sides, giving you x minus 1 is equal to y raised to the power of 3, and then take the cube root from both sides. So y is equal to the cube root of x minus 1, and that would be your inverse function. F of inverse of x, inverse of f of x would be equal to the cube root of x minus 1. Alhamdulillah, that's it. Assalamu alaikum wa rahmatullahi wa barakatuh. See you next time.